All right. We're going to work with a problem today about a bug on a piece of paper. This is kind of our intro to parametric equations. In this story, this bug is traveling across a piece of paper, and he starts out at the point 3, 2, and then that's 0 seconds, so 0 seconds is your starting point. After 5 seconds, he's at the point 6, 4. After 10 seconds, he's at the point 9, 6. At 15 seconds, he's at the point 12, 8. And then we're asked to predict where will he be at, say, 25 seconds or 27 seconds. And what we're going to do is we're going to make a little table here that shows where the bug is at certain times. We're going to record our data in a table form. And we're doing that for a good reason here. First of all, we're going to try and come up with some sort of an equation that might help us. And the table is good for that. So let's see. At the 0 point, right, x is 3 and y is 2. And I left 1 here. At 1 second, left that blank for a second. At 5, we're at 6, 4. At 10, we're at 9, 6. At 15, we're at 12, 8. So it looks like every 5 seconds he moves 3 spaces forward. So I suppose from 15 to 25, it's a jump of 10 seconds. So he's going to move a total of 6 spaces forward, not just 3. So that's going to be 18. And then his y coordinates are going up by 2 every 5 seconds. So after 10 seconds, I suppose he'll go up 4. And that'd be 12. Now, we could do using that, we could easily do, in times like 25, 30, 35, 40, anything like that, because we're just going up by, the x coordinates increase by 3 and the y coordinates increase by 2. But here we got this odd number, 27. So that's kind of like in the middle there. It's going to be a little trickier. So what I like to do is I like to go back now and figure out where's the bug at 1 second. And this actually isn't so terribly complicated. The bug goes from 3 to 6 in 5 seconds. So that's an increase. The x coordinate increases by 3 units in 5 seconds. So we would assume he's going at the same rate all the time. So from 3 to 6, that's 3 units per 5 seconds is 3/5 of a unit per second. And then here we've got 4. Let's see, it goes from 2 to 4 in, 2 to 4, that's a jump of 2, and does that in 5 seconds. So that's 2 units divided by 5, so it's a 5-second interval. 2 units divided by 5 is 2/5 of a unit per second. And if we look over here at our graph, we think about this for a bit. Okay, we're traveling up, so I'm going to break this down into as best I can. Right, 1, 2, 3, 4. Okay, so it's going up 2/5 per. So it's going to probably write this out very well. So it's easier to do. We start at 3. Here we're at 3 and 2/5. We added 2/5. Right. Every second we're going to add 2/5 going up. Okay. Next is here. It's another second. So that's going to be another 2/5 of a second. So that's 3 and 4/5. All right. Then we're up to here. So that's another 2/5 of a second. So that's 3 and 6/5, which actually is 4 and 1/5. And notice we've just moved past the 4 mark on the y-axis. Next we'd have up here would be 4 and 1/5 plus 2 additional fifths is 3/5. And then finally our last step would be adding another 2/5, which is 4, and 5/5, which is actually 5. So if we break down the entire change in y movement, so the change in y movement was from 2 to 6, right? 2 units, we break it down into 5 equal sized pieces, you're just dividing by 5. So 2 spaces of upward movement divided by 5 seconds will be 2/5 of a unit per second. Yeah. And we can verify just by adding it over and over again that we get from 3 to 5 or from 2 to 4 in 5 seconds. All right. So now that we know how far the bug moves in the x direction and the y direction every 1 second, now it's pretty easy to figure out what it's going to be for any number of seconds, such as a weird number like 27, because it's just going to be 3 plus whatever this is, times 27. So let's see, so it starts at 3 plus 27 times 3/5. So let's see, 27 times 3/5 is 27 times 3 is 81. That's 81/5. 3 plus 81/5. 81/5. The 80/5 would be 16. So that's 16 and 1 left over fifth. So that's going to be 19 and 1/5. And as for the y, well, we started at 2. And we're adding on 27 increments of 2/5, so that's 27 times 2/5, which is 2 plus the 27 times 2 is 54/5. That's 10 and 4/5, so it's all together 12 and 4/5. Oops, I'm off the screen a little bit here, sorry. Not paying attention. So again, we start out with our initial starting coordinate, 3, and we're going to add 27 increments of 3/5 each. So 27 times 3/5 is 81/5, which is, 81/5, which is 16 and 1/5, plus our original 3 makes 19 and 1/5. And here, for the y coordinates, each second takes us 2/5 up in the y direction. So 27 increments of that 2/5 is 27 times 2/5, which is 54/5. Of course, we have to add on the original 2 that we started with to give us 12 and 4/5 altogether. Now notice, we now have enough to put together a formula for this. So we start out with our x coordinate at any time is going to be equal to our starting x coordinate, which was 3, plus t, our time, times in seconds, times that many increments, 3/5. So we could write it as 3t over 5, or 3t over 5, or 3/5 t. So the starting coordinate plus t increments of 5/3. And as for the y coordinate, well, the y coordinate is the starting 2 coordinate plus t increments of 2/5. So 2t over 5. And what we have here is a description of this line over here, of this line right here, in what's called a parametric form. Right? So, and you can think of a parametric form as we introduce some new variable, and it's often easy to think of it as time, and we're imagining that the point is moving, or we could think of it as a bug. The point, is moving across the coordinate plane, and its position is some function of what time it is. So the x and the y coordinates are both calculated independently. All right. So x coordinate is calculated as 3 plus 3/5 t. And then the y-coordinate is calculated as 2 plus 2/5 t. So if I want to find out where the point is at any given time, I just plug a number in for t, my time, and do the calculations. I get xy coordinate and I plot them. And this is what's called a parametric. These are parametric equations. Okay. So instead of thinking of what we often think of as like the x-coordinate, we feed in an x-coordinate, we output a y-coordinate. We're thinking of the x and y coordinates both as separate outputs, and we're inputting some other variable like time. It's a little complicated, but I think this basic problem isn't too difficult.